Hello and welcome to the sixth session destined to software developers. Today we will discuss about fundamental software design principles for quality coding. Let me share also the presentation. Few words about me. So, as you probably have seen on the presentation, or let's say the webinar page, I'm a software architect. I have more than 24 years of experience in different areas of software development, and I'm very passionate about software engineering, good practices, and that's why I was thinking that it's a good opportunity to have such a presentation. We'll have a lot of things to discuss, so probably you have to move pretty fast. In the end, we'll have a coding session, at least to go through some samples on area of solid principles, just to see how we can redesign existing code, or refactoring, how it is called. The topics for today will address a bit why it's important to discuss about software design principles. We'll have a lot of things to go through regarding different principles, starting with solids and ending up with coupling and a lot of other interesting things, I hope. Short summary and of course Q&A session. So let's get started. Why do we need software development principles, or design principles? In the end, it's just a set of guidelines to help developers in creating good software designs. As we probably know, or all of us know, we are spending a lot of time not actually writing code, but reading code. So code that we got as part of a project that was already written by others. And in some cases, our own code that we have developed a couple of months ago, and a new change or a new requirement in the end will get us back to what we previously created. So it's good also to have the code in a good shape, easy to maintain, easy to understand, easy to read, and of course to extend it. Some common principles, it's solid, and so on. There are just a few of them here, even though there are a lot in the end. But in practice, depending on the technology, frameworks, languages, there are specific principles that can be applied for particular cases. As I said, in the end, we'll look over some sample codes. It's a GitHub repository that it's possible to access when do you want. It will stay on GitHub all along. The code is organized in two folders. It's before and after. Before will contain let's say the code with some issues, and after will be the variant with some refactoring applied. There are just simple samples, not full working application or something. It's just restricted to the concept itself, trying to make the code as simple as possible in order to be easy to cope with. We'll start with solid principles. It's an acronym. Each letter refers to different principles. It's single responsibility, it's OpenClose, list of substitution, interface segregation, and dependency inversion. And we'll discuss about each of them. And in the end, as I said, the code that we are going to look at will contain some samples for each of these. Single responsibility stated that every module, class, or function, or let's say functional module in the end should have just a single responsibility. Why this? Because in the end, if a piece of code will have different responsibilities of different things to deal with, actually will be extremely difficult to work with in the end. We'll need to spend a lot of time in order to be able to do changes, and a lot of other problems that we'll see immediately how we can deal with. So as a conclusion for this part, I know we got pretty fast, but we have a lot of material. That's why I'm a bit in a hurry. So single responsibility principles, what we have to keep in mind, it's the fact that it's good as much as possible that our code or a piece of code to have just one single functionality. Of course, it's not a matter of just having a single instruction in a function, or a function with a single instruction, or a small module, or things like this, but it's related to what the code should deal with. So if we'll have for example, an invoice service that will have functionality to add an invoice, to delete an invoice. We need also to validate it, and log errors, and notify the customer about that invoice. This service, it's dealing with a lot of different functionalities that are not necessarily belonging to the invoice itself, like, for example, sending email, or the error logging, or even the validation. So we can isolate the responsibilities or categorize them into two areas, like own responsibilities of this invoice service, and extra responsibilities like validation, logging, sending email, etc. So after separating these functionalities, we'll end up with an invoice service that will have functionality related just to invoices. We have a validation service, a logger service, and an email service. Next, it's OpenClose Principle. This, even though sounds a bit weird, the idea it's in the end that a module or a component, a part of code, should be easier to extend, so open for extension, but close for modification. So the idea is to prevent that an existing piece of code that was already tested, it's already in production, works okay. We have to prevent the changes, because each change that we are going to perform against it will require, again, testing, validation, and yeah, a lot of, in the end, it's a risk that something that was already working, if it is changed, it can have, let's say, undesired behavior. So we should keep what we have working closed, so to don't touch what it's in place. But if we need something new, then we should find a way to extend existing functionality without altering the existing source code. How we can apply OpenClose Principle? So we can create new classes derived from the existing ones, and it's also possible to use abstractions, so to create abstract classes with some common functionality, for example, and what we need to add, we should add into the new created classes. So if we are not going to follow OCP, so open close principle, as I said, it's possible to introduce undesired behavior, so things that we're not thinking that can break, but it can happen. And of course, we'll need to spend a lot of time doing regression testing and following the pyramid of testing to be 100% sure that we haven't damaged anything. Yeah, so mainly it's about this principle. It's important to follow, as I mentioned, because of these reasons. Next on the list, it's a list of substitution. It sounds a bit weird, but it's in the end pretty simple. Think in terms of inheritance. So if we have a parent class or a base class with some functionality, we can say that this principle it's functional, it's working if any derived class can be used instead of the base class that it's inheriting from. So it's simple like that, nothing fancy, nothing complicated. But in some cases, depending on languages, technologies, it can happen that derived class can change the interface of the base class, and in this case, the list of substitution principle is not possible to be applied anymore. Next, it's interface segregation principle. The main idea here is the fact that we should not expose more functionality than some consumer code is interested in. So, for example, if we have large interfaces, for example, like in an order, like we have seen, if we will expose also validation functionality or different other things, in the end, it's possible that a consumer of that class will have access to functionalities that he is not really interested in. So we should limit as much as possible the functionality that an interface exposes to what it's intended to be used in certain context and by certain consumers. Yeah. So next, it's a dependency inversion principle. It's let's say a matter of low coupling and high cohesion. The idea here is that it's, for example, in a piece of code, we'll have strong dependency on other classes, other objects when this is going to be instantiated. So, for example, if in an order we'll have a list of customers that are part of the order class, then it's Yes, the document will be available. I will place it on the GitHub, answering to a question on the chat. So if we have these strong dependencies, in the end, it's very difficult to change the implementation of a certain class because of these dependencies. So it's not really possible to, for example, test such a class because we have strong dependencies inside, and it's not really possible to use fakes or mocks for this purpose. So the idea is to invert the dependency. So instead of depending on real objects on our implementation, we should find ways to have these dependencies on abstractions. So we have to have, for example, interfaces or abstract classes that our class will depend on, and will be much simpler in the end to inject, for example, fake classes or other, let's say, helpers or ways of testing this. Probably it's a bit confusing. We will go on the codes, and will be much simpler to explain based on that. Yeah, so the conclusion here is the fact that instead of depending on specific classes, on specific things, we should try to find ways to decouple. And this decoupling can be done by using abstractions instead of specific implementations. Yeah, so in few words, these were the solid principles. I know we went pretty fast through it. As I said, it's a lot of material. So in the end, the conclusion is that for object-oriented programming, these principles, I mean solid, so single responsibility, open-close, Liskov, substitution, interface segregation, and dependency injection can be applied in order to keep our code as simple as possible, removing hard dependencies from it. So use always abstractions instead of instead of real objects. So yeah, in the end, it's a matter of simplifying as much as possible our code and remove dependencies. Next, we are going to some other topics related to principles. It's and we'll start with Boy Scout rule. It's inspired from the Boy Scouts of America, and they have a simple rule, so leave the campground cleaner than you found it. What that means in programming, so we should always try to clean up our code, or the code that we have to work with on each time when we are going to look at it. For example, if we are reading the code, we'll find a bad name, let's change it. If, for example, we will find that there are some comments that are no longer reflecting what the code is doing, in this case, we have to remove them. And always it's good to take out any comments and use more explicit names, or names that are revealing the intent instead of comments. For example, we have in many old code bases a lot of comments. If we are coming, for example, from the .NET world, I'm not really sure on Java, but probably it's the same, with some comments on methods, on classes, about the intent and what it's actually supposed to do, and also what parameters methods has. And in the end, we'll find out that the names of the parameters were changed, maybe the types and also the number of parameters. So the comments are no longer reflecting the reality. So in this case, it's better to remove the comment and maybe change the name of the method in such a way that it's self-revealing the intent. For example, also the if statements can be also simplified if we have on if and else branch the same statements. Maybe we can refactor a bit and extract them outside. If we have duplicated code, again, maybe we can remove the duplication, and so on and so on. So these things are also in what it's called clean code. It was a book probably you have heard about from Robert C. Martin, that it's very explanatory about what clean code means and what we should do to keep our code as clean as possible. And the Boy Scout rule, it's let's say the starting point in all this stuff. Next, it's dry principle, or don't repeat yourself. The idea behind it's pretty simple. Almost all these principles are in the end pretty simple, but they have a huge impact over the quality of our code. So in case of dry, the idea is to have the duplication removed, and we should have let's say a piece of code that it's duplicated, that appears in many other places just once in a deployment unit. That can be an app, library, or other type of let's say module or deployment unit, as I mentioned. So the code that it's common should be refactored. Now depends on where the duplication is found. For example, if we have a duplication in classes, then maybe we can refactor and extract the base class with what it is common for the others. Or if it is on functions or methods, we can create just a single method. So it's a matter of context. Depends on the code, what is duplicated, what can be done. So the idea is to have just one single piece of code that it's doing any logic or any action in the end, to avoid repetition. Some common violations, magic values. We have in some cases different strings, for example, in messages that are returned to users. Or different numerical values that are used many times. So compare, for example, if it's less than pi, or if it's greater than 100, or things like this. So it's not really possible after a certain amount of time to remember what that 100 means. And yeah, if I don't know what string, maybe it's no longer what it should be, but this is a different area. So in the end, magic values refers to hard-coded strings or numbers or other values that can be replaced with constants with meaningful names. Also, repeated code, we can, as I said, refactor to methods or classes, and so maybe we can apply the strategy design pattern that it's not presented here, but just to understand what it's about. It's like in real life to have some options. For example, if we want to travel from point A to point B, we can choose a bus, a car, or the bicycle. So let's say choosing the bicycle, it's one of the strategies or the possible strategies that we can take in order to travel from point A to point B. So this is the idea in few words. So in this case, maybe this repeated code, but not necessarily the same code, but it's possible also to have repeated logic. So the code is not really identical, but it's doing the same thing in the end with different instructions. So it's again a kind of duplication that we can get rid of by applying this refactoring or strategy design pattern. Encapsulation refers to the idea that objects should manage their own behavior and state. So we probably know from object-oriented programming, but it's not really limited to it. So it's also possible to have requirement or a requirement to prevent also the access to different state or behavior in different objects, and we should try to keep this encapsulation. Of course, different languages offer functionality to, let's say, prevent the access to internal state or internal behavior. But it's always good, for example, to limit the access to members or to fields, to don't expose for example, field as public in order to allow undesired changes. So it's good always to start to, let's say, with the most restricted access possible, and then relax these constraints or restrictions when makes sense to be relaxed. So, for example, probably from the beginning we will know that some methods should be public, but maybe one of these it's not really 100%, or we are not 100% sure that it's really required to be public, so maybe it's good from the beginning to set it as private, and in the end to see if it's something that we really want to present or not to the outside world. And here it's a small sample. If we have a product with a field, member variable, that volume, as we can see, it's public, so it can be accessed from outside, and there is no control possible to be applied over the change. So anyone that gets an instance of a product can change the volume in the way that it wants. So one possible step is to create or let's say create a property, so to update double quotes this field to a property. If we are coming from Java or other languages where there are no properties, can be getters or setters or accessors or mutators. So can be different methods for this purpose, but the idea in the end is the same. So if we'll have a property, at least we can have some validation implemented on the setter. So this fields will not be possible to be changed without performing some validation, some checking. If something is wrong with it, then we can inform the consumer that something was not okay. So as we can see in this case, an exception will be thrown if the value will be less than 0. So it's just a sample, as I said, but the idea is to have some validation, basic validation for it. And what can be done next? It's for example, to extend a bit. If we look again, here volume, it's a property of the product class. And what we can do in the end, it's to extract this volume in its own class and have all the functionality related to the volume implemented here. And this volume, if you will watch the previous presentations related to domain-driven design, can be treated as a value object. So something that has value and it's self-contained in the end. So here we have amount. It's also possible to have some constraints related to the unit of measure and let's say that amount it's as we have seen validated, and also the unit of measure. So it's more self-contained, more descriptive in this way. And in the previous example, instead of having this volume here in the product, we have to use the class volume that we have just seen. Next, it's the principle of the least astonishment. It's all about predictable behavior. So the idea is to have the functionality implemented as it is expected to be. So, for example, if we need to implement the functionality of command panel of an elevator, if we have a button with an arrow that points upwards, then if the functionality is implemented to stop the elevator or to go downwards, it's something weird. So it's something that we are not expecting. And this is what this principle is referring to. If we'll have a piece of functionality, it should actually do what it's supposed to do, or at least what, let's say, it's trying to make the user aware that it's going to happen. Yeah, so to don't do something else than it's obvious to happen, or it's suggested that will happen. Yeah. Next, it's don't call us, we'll call you, or the Hollywood principle. And this is closely related with dependency inversion. This dependency inversion, as I have said, it's just a matter of not having strong dependencies. So instead of depending on instances of different classes, we should depend on abstractions. So in this case, the idea is to, as we'll see next, the idea is to have a way, some hooks or plugins that will, for example, if we have some functionality that's implemented in external component, then our program should not monitor all the time what it's happening. So we should not block the functionality of our program and wait till that plugin or other component is doing its job, but the other way around. That component should actually notify when the processing was finalized. So don't wait or don't call for checking if a functionality was done, but wait to get notified when that processing it's performed and execution is done. Next, it's keep it simple or stupid or whatever the latest S means. Here it's a principle that it's stating that we should not overcomplicate things. So keep things as simple as possible and always ask yourself if it's really required to implement something in a complex way, or we should over-engineer different things, or we should keep what we have to implement as simple as possible. So it's always about trying to find the simplest possible way to implement something. And of course, maybe sometimes, and this it's also related with you are not going to need it, as it's mentioned on the bottom. So think if we really need that functionality, maybe we are going to think, okay, but in the end, this functionality for sure, it will be required. But in most of the cases, it's a matter of avoiding to take some decisions that are not based on reality. So don't make assumptions, because for example, a customer maybe will not need that functionality. So or he or she will change his mind, and in the end it's just time spent for nothing, and as much code as or let's say if we'll have a lot of code, in the end it's a debt. We need to test that code, we need to maintain it, and yeah, always be sure that we still need that part of the code. And yeah, it's just a way of wasting time and resources. One question. So what it's asked, it's if in this way the design that we are creating is not ready for future development. Not necessarily. So if we have a list of requirements, then it makes sense to think what we should do next. So, for example, if we are thinking in agile terms, then we'll have a product backlog, and based on the product backlog, we as architects or developers, we can think, or let's say in our mind, create the big picture of how the thing should look in the end. Based on this, we can, for example, implement some functionality that is not really required on that specific user story, because we will need this to connect with different parts of the functionality, or different part of the system, or different other possible scenario. But it's based on something that it's in the backlog. Of course, it can happen that in the end that functionality maybe will change, or let's say we'll have the priority changed, or instead of something must have, will become nice to have. So it's always a risk. Of course, if there are non-functional requirements, things that not necessarily related to the application itself, but to the infrastructure or the technical environment, in some cases we can decide that okay, we'll need this additional piece of functionality because of, but these are, let's say, exceptions or particular cases. In the end, here, what we have to understand from these principles, it's the fact that if it's not required to have it, don't make assumptions. So don't implement parts of the functionality just because, or it's fancy, or it's interesting to implement this because, yeah, I don't know, whatever other reasons can be. Of course, if we are developing libraries, then it's of course a different story. The idea of a library is to offer, let's say, functionality that it's referring to whatever part of the functionality that we want to support or to help with. In that case, of course, it will not be possible to say 100% that certain methods will be required or not. But yeah, the idea, as I said, is to keep things as simple as possible. Excuse me, and to question yourself, or always question yourself if something is really required or not. Next, it's persistence ignorance, and here it's yeah, maybe not always very clear that this is a principle or very obvious, but this has the root in what we have now as object relational mapping frameworks, and maybe other areas that have a kind of similar behavior, where different persistence details tend to be included in our classes, in our functionality that it's trying to model the business behavior. Also, it's a problem with these details related to storage in data-centric architectures. So if we are starting the design based on the database, for sure we'll end up in a a model or with a model that will contain a lot of details related to tables, to IDs, maybe relationships and other details related to database that actually makes no sense from the business perspective. So our models, domain models, should be kept as clean as possible of this, let's say, storage related details. Of course, it's not possible in all the cases, but there are ways of let's say, isolating the domain and focus on the business logic from the beginning. And this is what domain-driven design is actually promoting. And in the end, let's say, storage and where to place it, it's just a detail. So we'll not have too many, or will not be very important if, for example, we'll have a relational database, or it will be a NoSQL database, or it will be something else where we are going to store the data. So persistence ignorance, it's a very helpful principle in order to avoid these details related to storage to propagate in our business objects or business related objects or domain. Yeah, separation of concerns, it's related to single responsibility principle. It's let's say a principle that it's more general, that single responsibility. As SRP, it's referring to parts of the code, classes, methods, even modules. Separation of concerns, it's more related to architecture. So we have to understand this principle in the context of the whole application, how we should organize the architecture in such a way that different parts of it will have specific functionality that will not interfere too much with other components. So the idea is to avoid dependencies, to avoid to put different parts of the functionality where they are not actually belonging to. So with the help of separation of concerns, we'll have some advantages. Our code will be much clean. We'll have less coupling, and it will be much easier to maintain that piece of code. Why? Because dependencies are the root of all evil in software development. So it's impossible to test, it's impossible to change, it's impossible to extend a piece of code that has a lot of dependencies. And for example, if you want to change something, it's possible that instead of changing a line of code, to change in maybe 20 classes because of whatever dependency that happen to have in the piece of code that we have to change or to update. So this is why we should keep this separation of concerns or single responsibility in mind. Of course, it's not always 100% possible, but we have dependency inversion. as a way of reducing the coupling between different parts of the application or different components. So instead of using for example, an instance of an object in a class, we can just provide that instance via the constructor or via a property or other ways, depending on how this dependency injection is implemented by different frameworks that are created for this purpose. So in the end, we'll have just some abstractions that our piece of code is depending on, and we'll just keep things much easier to maintain and to change. Of course, there are disadvantages also in that case, but for example, if we have dependencies, even though they are inverted, in a big number, so it's acceptable to have, for example, 1 or 2 dependencies. As less as possible, as better. So if we have more than 3 or 4, then it's a good indicator that our piece of code is doing too much, and maybe we can do some refactoring and move some part of the functionality from that class in the classes that we are trying to use as inverted dependencies. So maybe that class exposed too much functionality, and we can refactor in such a way that the functionality is more located where it actually belongs. Yeah, so it's also related to this separation of concerns to feature sets, but in the end, it's a matter of what I already discussed about. Next, we have stable dependencies as a principle. The idea here is that in modern software development, we'll have a lot of dependencies between what we are trying to create and different frameworks, different packages, different libraries. So it's not really possible to start and develop everything from scratch. We always are using different third-party components that we can reuse in order to, let's say, reduce the development time, because it supposes that these components are stable, are tested, and in the end they will benefit on our development speed. But it's not always like this, unfortunately. Being, let's say, in most of the cases, an open source market, in the end, to say like this, it's difficult to have good control. Sometimes different packages are developed by just a single person, or maybe a small community around that project, and they, as long as are not getting any money, will not have enough time to test it or to apply best practices or different other things. So it's not really safe in all the cases to use third-party packages. So normally we should test this very careful. And in the end, it's a question if it's something that we should use by granted, or we should try to maybe develop something by ourselves. It can turn out, and I say from my experience, that It can take a longer time to use and integrate such a third-party package than developing by yourself. But yeah, this is another story. So the idea here is to, let's say, being sure that we have dependencies on packages or frameworks or libraries that are stable, and yeah, I mean, we should test and be careful about using them. Next, it's tell, don't ask. It's also related maybe in some regards with what we already seen. So the idea is that instead of, for example, interrogate an object for different properties or different other ways of changing the state and having a trail of names, so getting a property, then calling another property of it, and so on and so on. So to have trails of members that are accessed. The idea is to try to keep the encapsulation. So to avoid to expose too many things or too many details about the state of an object. And here it's related to flags over objects, and that means, in few words, that the behavior of an object it's dependent on some flags or some conditions that are in different parts of the code in a different object. So if I have object 1 and I'm choosing object 2, then in some cases, and probably you have seen this a lot in code, if whatever condition, then we'll do something with part of functionality from object 2. Else, do something else with different part from object 2, or set different values depending on the condition that it's tested. And this, it's really an anti-pattern. So we should try to avoid to have the state of an object changed from outside. So in that case, that object, it's just a bucket with some properties or whatever functionality, and it's not responsible for that state that in the end it has. So, and that it's really an anti-pattern. The object should be self-contained and should not expose more than what it's really required. And in this case, is not really necessary to have that. Dynamic domain model refers to the objects that have only properties or methods to change or get the values of these state variables. So we'll not have any logic to perform any action implemented in their level or at their level, sorry. So in this case, they are just a bucket of properties or the state values without any logic. So they can be like DTOs, data transfer objects, but only for that purpose. Again, it's an anti-pattern. We should try to avoid to have just these anemic models. Of course, it's more in area of DDD, but it also can be connected to this principle, tell, don't ask. So instead of asking for properties, give me the property that I can interrogate to get whatever value, I can ask, give me the value. and that object should be responsible to do the processing and return the value that I'm asking for. So this is the idea here. And sample, we have this CPU monitor class with a public value property. And it's a client class that it's just getting a list with this CPU monitor instances, and we'll iterate through each of them. And if the value is greater than a certain value, a certain amount, sorry, then we'll get an alert. Doesn't matter what alert, but the idea here is that this client it's interested in this value, and of course the client should know that the value should be greater, or let's say value 90 makes some sense for client instead of making sense for the CPU monitor itself. And again, 90, it's what we have seen, like a magic value. What 90 means? Maybe it's temperature, maybe it's something else, we don't know. So how we can refactor this? We will do some changes on the CPU monitor. So instead of having just this value, we are going to implement a mechanism that it's getting a threshold alert that in the end can be that 90 that we have seen, but in this case makes sense because it's a threshold, it's something explicit. In this case, it's a variable, so it can be provided via a configuration file, for example. So it's not necessarily hard-coded. We still have the value, and it's a property that will get a Boolean result, or will return a Boolean result if the the condition it's true, as we have seen. It's compared with 90. Here it's greater or equal. Yeah, doesn't matter. It's just a detail. And in the client, we'll have an alert service that again will iterate through the list of monitors. And now, instead of comparing with 90 or whatever other value, we'll just call this exceeds threshold. And in this case, client will know not that many details about internal working of the CPU monitor. And we can refactor this even further. So instead of hard coding the processing or iteration via the CPU monitors, we can have kind of reference to a function with that action if you're coming from a .NET world, or it's a pointer to function or a reference to a function if you're coming from other technologies or languages. So in the end, the CPU monitor will get the threshold, and will get the pointer or the reference to that function or method that will actually handle the situation, the case. And all the other things are the same. And in the end, the sample method that also belongs to the CPU monitor will test for the threshold if it is exceeded or not. And we'll actually call that method. And the client will be like this. So in the end, we'll have only the CPU monitor dot sample, and all the processing, everything will be done in CPU monitor class itself. A short question regarding if it is recommended to write our own framework or to use an already available framework supported by the community. This is related to the previous topic regarding stable packages. It's hard to say. Sometimes the time that it's required to spend in order to implement some functionality, it's considerable higher than just getting that component. It depends if you need very complex functionality, for example, like a JSON parser, processor, with serialization, deserialization, and so on, probably it's overkilling to start to do it by yourself. But for simple cases where you need just one or two functions from whatever library, maybe it's cheaper to implement by yourself. So it depends again on the context. Now, getting back to this, so as we can see, it's a matter of having all the required functionality in this CPU monitor, and where it is required, we can just use a method that will perform all the logic. So this is a good sample of how the thing should be organized. Instead of exposing too much, just keep the things as encapsulated as possible. Next, it's you ain't gonna need it, or you aren't gonna need it. It's yeah, a term that it's interchangeable. Doesn't matter that much. The idea here is that, as I said, we should question ourselves if it's really required to implement something. And maybe we can postpone to implement things if it's part of functionality that we don't really need to have it to implement, let's say, what we have to do. Then we can maybe think in a different way and say, okay, let's not do this. And this approach has a lot of benefits. In the end, as is stated here, it maximizes the amount of unnecessary work. Of course, in the end, we'll be required to implement something, but we don't know. Don't make assumptions, don't think in advance that let's implement also this because yeah, for sure we'll need it. No. Try to be as lazy in double quotes as possible and don't do that. So leave what it is possible to don't be implemented or postpone it as much as possible. Because in the end, it's possible to turn out that or it's not really required to have it, or the requirements were changed in the meanwhile, and yeah, that functionality may be instead of being mandatory, it's just a nice to have. So things like this. just focus on the code that you need to implement and don't try to do more than what is really required. In the end, the code that we have, it's required to be tested. If we are following TDD approach, so test-driven development, we have to write tests before writing the code. It's not sufficient to have only unit tests. It's required to have integration tests, and it's required to have acceptance tests, performance tests, a lot of other kind of tests that if we don't have any code, it's not required to implement. So it's not only the method that we want to implement, thinking that for sure this will be required and maybe will not be, but it's a matter of testing it. If there are regulations in the area that customer it's doing business, it's possible to be required to document very thoroughly what that function is doing and so on and so on. So it's a lot of time spent for something that maybe in the end will not be really required. Yeah, so this is the idea. And of course, it's closely related with keep it simple. So these two things are working hand in hand in the end. Yeah, next it's law of Demeter. And we'll have a sample to look at a bit later. This is the principle of least knowledge. So it's related to behavior, to how a specific part of the code should interact with other part of the code. So just in general terms, it's don't talk to strangers. So don't try to interact with classes or objects that are not necessarily involved in what you have to do. So don't expose too much to others. Do not do method chaining communication. Again, don't expose too much to others. Inviting different classes or other programmers that are using your object to use different properties that can change in an uncontrolled manner the behavior. And of course, it's something that increases the coupling between classes. If you are exposing too much, you are actually create a coupling between your object that it's offering this access to internal behavior or state to others, because they will depend on our object and it's not necessarily what we want to do. And only talk to your immediate friends, and that it's related to what we'll see next as high cohesion, how it's called. So to keep related things close together. So, as I said, the primary goal is to prevent external objects from gaining access to internal state of our object or our module in the end, because we can extend a bit and think in terms of module or components that we try to prevent from getting access from outside in an uncontrolled manner. And if we want to have this law of Demeter applied correctly, we should apply aggregation. So to keep things as connected as possible. It's not necessarily the aggregation from object-oriented programming. Here, it's more like a concept of aggregation to aggregate functionality. It's yeah, composition and good encapsulation at each level. Next, and we are getting closer to end with the first part. So the loose coupling. Loose coupling, it's something that we really want to have. So to keep the functionality of modules or components or classes, functions, whatever, methods, as independent as possible, to minimize towards zero the dependencies on others. Of course, it's not necessarily also possible to do this, but using dependency injection, as I mentioned already previously, it's one way of breaking these dependencies. Yeah, so mainly it's a matter of keeping things as independent as possible. High coupling would mean that a module or component or whatever knows too much about the inner workings of other modules. So it's something that we will want for sure to avoid to have. Right, it's the high cohesion. It's also in connection with loose coupling. Normally they are opposite. If we have a loose coupling, for sure we'll have high cohesion. It's not 100% the case, but usually it happens. But anyway, we should aim for high cohesion, so to have all the functionality related to I don't know, part of the code or whatever we want to achieve coupled together, so to stay together actually, being self-contained in a component. And yeah, of course, it's by keeping high cohesion, it's also a way of getting rid of duplicated code. Because usually if we have yeah, not necessarily big, but significant code base, it's also possible that different developers from the team to implement functionality in a similar way instead of reusing the code that already exists, or in some cases, and that's the worst possible scenario, or just copy paste the code. And this duplication also refers not only to code, but also to, for example, tests. Of course, tests are also production code, or it should be production code, but there are a lot of copy pastes in case of tests. So here it's also an important thing to do refactoring and to reduce the duplication of the code in tests, because the tests are usually treated as a second hand citizen, or second level citizen, and usually in our code we'll have a lot of bad code and bad approach in implementing tests. Yeah, and low cohesion would mean that the code that makes some functionality, it's spread out all over the code base. So it's actually how it should not be. That's why it's mentioned here that high cohesion actually means to try to reduce duplication because of this real life scenario that we have this duplicated functionality in different places. And of course, it's related to encapsulation because high cohesion in the end means good encapsulation of the code. So to keep things that are belonging together tightly connected. It's a law of Demeter that if it is applied correctly, again, will help to keep related things close together. So we can think after applying these principles that our code will be more componentized, more independent. So each part of each component, each module will be independent from others. The dependencies will actually be done via loose coupling. So if of course it's required to exchange data with other modules or components, or to use the functionality of others, but tell don't ask, for example, it's another way of not exposing too much. It's about creating kind of an API on each module level that will be used by other components in order to get some functionality performed for them. So if you need whatever thing to be done, then instead of doing by yourself or asking details about how to do it, or even worse, accessing directly some internal functionality of an object to call it and getting or let's say providing some data, and after that getting some result, you can just ask that object take this value and do this for me, and in the end you will receive a value. Or if something is wrong, we can get an exception or get notified about exception, because it's another topic that it's related to command query separation, for example, in code that states or recommends that we should have commands. So what it's doing changes on the state of whatever class, not class, sorry, object or module or component, should not return a result. And we should have queries that actually it's the way of getting the result. So separating what mutates state from what it's querying the state. So yeah, this is it's another topic to discuss about. And so we can start to look now on some samples. I will close the presentation and share the screen for this. Okay. Just a second. Are you able to see the GitHub? Okay. So here it's, as I said, will be published also the content of the presentation, the slides. We have some code for solid and for law of Demeter. The others are more theoretical. There are concepts that we discussed about, and it's not necessarily some good example for them. And in some cases, I use the slides to have the code presented. So first, it's single responsibility. I don't know if it is big enough. Maybe it's better like this. So it's before. Here I will present directly this. I'll not open any IDE or something. That's not that important. So it's what we have seen. I'll get back to the slide. It's here. So we have this invoice service. It's add, delete, validate, error logging, and send email. And we have identified responsibilities, and this is the final result with different services or components or whatever you want to call it that have specific functionality separated. So we have the add method that it's receiving an invoice. This is before. So in the case where invoice service knows details about everything. So of course, add and delete. As I said, it's just the minimum amount of code to implement these kind of things. So add, first we will validate the invoice, we'll write code for adding the invoice, whatever other it's required, and if everything is fine, then we'll create a mail message. This it's using in .NET, it's the mail namespace that contains this mail message. Probably it's something similar more or less in Java or other frameworks. And in the end, we have a method to send the email. So, of course, this is a service. This is a third party that it's taking care about the invoice. In this case, the invoice, it's just a matter of exchanging data. So to think from the perspective of, for example, persisting the invoices or performing some actions against some invoices. It's not related to the invoice itself. It's some functionality performed against some invoice or using some invoice, and it should do a lot of other things. So we have the delete for the invoice. Again, should validate if it's the data it's valid, and in the end this should be removed. And logging here, it's just a matter of writing in a text file. The validate method, it's also implemented here at this level. And the send mail, send email, it's also in this invoice service. So here we have everything, and this is more than just taking care about the invoice. It's validating, it's sending emails, and so on and so on. The invoice, it's pretty simple. It's just amount and date. And program, it's more or less empty. No, doesn't matter that much. So as we have seen, everything it's in this invoice service. How it can look after? A lot of other things. As we have seen on the diagram, on the picture, the idea was to separate each functionality in its own service. So we have invoice service taking care about the invoice. We have the logger that it's taking care about logging, and notification that will take care about the email. And as you can see, we have some interfaces that are provided via the constructor of the class. And this is an application of dependency injection principle. So the D that we have here in the solid principles, or dependency inversion. So the idea was to don't have dependency on the instances, so hard dependencies, but to depend on abstractions. And as we know, an interface, it's an abstraction. Of course, here we can have abstract classes where it's nothing to prevent that, but the idea is to don't have here, for example, like validation service equal new of validation service, and logging service equal new logger service in constructor, or to have like local variable. So someone is asking why in he is not coming from .NET, and why names are starting with capital I. It's the convention that Microsoft created. So there are some coding rules that Microsoft created in the past, and to use the capital I, it's recommended practice to have an interface easier to identify. So it's just a matter of naming. It's nothing set in stone. But usually in .NET, people are using I whatever as an interface. Yeah, so in this way, we can break that hard dependency. We can inject in the end in this invoice service other services that we can use to achieve different functionalities. So now this logger can be used, also the validation, and we'll see immediately the function that we previously have implemented in invoice service to validate. Now it's a member of this validation service, that it's getting an invoice and it's performing the validation. And here it's a matter of filling in some properties of this email service, and in the end we can call the send email method to send the email. Yeah, so this is how it can look afterwards. The interface, it's just as the name suggests, a matter of exposing the contract. So the details of the contract, that who is going to implement iLogger service has to implement in the end. The same for notification and validation, and we can take validation service because I mentioned previously. And we can have this validate method here. Okay, someone is asking about most of these principles don't fit in microservices. Agree or disagree? Why not? So these principles are not referring to microservices or to other software architecture patterns, except separation of concerns that can be applied also on the code level, but also on the architectural level to create separation between layers, for example. So it's a matter of taking these principles into consideration when you are implementing a microservice. So it doesn't matter too much on what architecture are you going to use. It's a matter of implementing code. So this is how the things are going to look like after we have split it based on the specific functionality. I will answer the question that was asked right now after we are going to finish, because there will be too many interruptions. Okay, so this is the single responsibility principle. If you have any questions regarding to this, please ask on chat related to this topic. OpenClose Principle. We have again before and after approach. Program, again, it's nothing to pay attention to, doesn't matter, and we have the invoice. Short break question. How deep can we go with single responsibility principle? It's not a matter of going to, or let's say deeper or at a higher level. It's just a matter of keeping things as, let's say, self-contained as possible. So if we want to change, for example, an invoice, we need to change at the invoice level, not into 10 other places to implement a change, for example. So it's not measurable in the end. It depends on the code that you have to deal with. But if you keep in mind this principle, then it will help a lot to have, let's say, encapsulated code with high cohesion, and that it's very loose coupled. Okay. Next, it's until we create auxiliary classes to do just one thing. It's not necessarily to create auxiliary classes. It's a matter of modeling and see how the thing should work. Or maybe I was not really understanding the question. So it's not auxiliary. There are just fully functional classes. And of course, these are just general principles. If you want to go deeper, you can approach, for example, domain-driven design and other concepts that will help a lot with designing software. Now, getting back to OpenClose, this principle was stating that class should be closed for change and open for extension. So if we need to add new functionalities, we should not change the existing code, but find different ways to add functionality in such a way that the old functionality is not affected. Of course, in some cases, it's possible that the things are so dramatically changed that it's required to change the original functionality. It's totally possible. But here the idea is if we don't need to change the core, the old functionality, then don't do it. Avoid to add, for example, in case of initially we had one parameter to a function, and now we need two parameters. Why to change a function that it's already working than implementing a new one that maybe will use the previous and do something additional? So these kind of things, try to prevent as much as possible to do changes to what it's already in place. So again, before, as we have seen, maybe was kind of interruption. We have just two things. It's the invoice and invoice type. So we have kind of final and proposed invoice, and here in the invoice we have something like this. Doesn't matter that much, we're just getting some data, populating some properties, and we have a get discount method. And here we'll get this invoice type that we have to take some decision based on the value. So if it's a final invoice, then we have to apply a discount of 100, whatever, let's say, lei. And if it's like this, will be just different discount applied, and we should return this final amount to whom it's interested in getting the discount. Yeah, kind of, let's say, pretty common thing, but it's not okay. Why? Let's see. What will happen if it will be required to add an additional discount? Maybe we can go back a bit and look again. It will be required to add here a new entry, and it will be required to come here and add a new condition, and yeah, it's possible to have some other changes, and again go in many places and change. Of course, here it's another problem with these magic values. We don't know, of course, can be some monetary value, but yeah, whatever can be. Maybe it's a mistake, maybe it's whatever, not necessarily amount as discount. Maybe it will be required that for other kind of discount to be a percentage. We don't know. So we should do changes in different places, and that's not okay. So we can have this get discount that it's doing something predefined. For example, just a small discount, it's applied. As we can see, we have an abstract class, so it cannot be instantiated. It will be just inherited. So we cannot have this used standalone. And we'll have proposed invoice, recurring invoice, and a final invoice. Final and proposed we have seen as a discount, way of computing the discount. Yeah, we just use the existing invoice and implement this get discount method, but it's overriding the method that we have in the invoice, and it's computing the discount with that -10, and additionally will subtract 50 from that discount. So in the end will be this final invoice discount. For the same for proposed, and for recurring will be something different. As we can see, it's a different type of invoice. So in this case, we can have something like this, or we can take some decisions because as you can see, we don't have the type anymore here. We can take some decisions at a different level, not necessarily in main, but yeah, it can be in a different place. For example, in a module that it's issuing the invoice, like the invoice service that we have seen previously. So depending on the type of invoice, we can get the discounts specifically for a specific, specifically for a type of invoice. And here it's something similar with that strategy pattern that I mentioned previously that we can apply. So instead of having that if else or switch or other kind of multi-decisional constructions in the code, we can use this kind of special classes that will encapsulate the logic for computing the discount or other kind of things, but discount in this case. Yeah, if you have some questions regarding this, or of course we have a session in the end or questions and answers. Next, it's a list of substitution. Before it's something like this. It's related to color. That's pretty strange, right? So apple, it's our base class. It can be a fruit, but in this case, it's just a matter of presenting a bit weird sample. So for an apple, we have the color, again, it's virtual, so it can be overwritten. It returns red. It's orange. This extends apple. So in this case, whenever we have apple, we can use actually the orange, because the apple, it's the base class for orange. So apple can be replaced by orange without any problems. And this is what list of substitution it's actually stating. So if S it's a subtype of T, then objects of type T should be replaced with objects of type S. So the base type can be replaced with subclasses of it. If we are deriving a class from a base class or type, we can use this derived classes instances instead of the instance of the base type. In this case, we cannot have, of course, abstract classes. Another question, you created some specific classes for every type and you delete type as a property. I'm not really sure what it's related to. It's related to list of substitution or to OpenClose, the question. OpenClose principles. Yes, we can have instead of having this, so it's related to the previous principle, OpenClose, where we had that enumeration with checking. So it's always good to create specific classes instead of having this kind of decisions taken inside of a class with if else's or switches or something else, because it's not really possible to extend if it's required without doing changes in many places. And if we have, for example, like in the case that we have seen an abstract base class, we can do very interesting things in code with these specific classes. So it's not a problem with the number of classes like it was, for example, in the invoices. We've had specific classes for invoices that we have seen. Questions if you have for list of substitution, if it's clear or it's pretty simple in the end. It's a matter of replacing a base class with a derivative. It's not always possible, as I said. It depends on the behavior of the derivative class or the subclass. Next, it's interface segregation. Again, before program, it's again empty. We don't have too many things here, and it's a matter of having this kind of printing related stuff. So it's inkjet, it's for scanning, fax, print duplex, and all these things are tasks for a printer. Oops, sorry. And for laser jet, we have again a lot of stuff. But if we are interested in just printing, we can see that we have also scan and fax. So these kind of things are not necessarily good to be exposed if we want to address just functionality related to printing, right? It's too much. For example, in a certain part of functionality, I'm not really interested in getting access to scan or to fax because I'm not concerned about it. So how the things can look like? We can separate in printer tasks and facts tasks. This is just for facts. And this is for print, scan, or we can just leave print or so. The idea here, it's not how it is necessarily in this pretty simple sample. The idea is to understand that if we have some functionality that it's exposed to external classes for consumption, it's too much. It's like in a contract. For example, if you are buying a house, of course, will be the selling contract, but maybe in the contract will be some clauses that you have to take care about the land of the neighbor and to clean whatever part of the land that it's far from your property, and to take care about whatever other kind of things, take care about the neighbor's kids or stuff like that, that are not actually related to the property that you are going to buy. So if you are going to sign something like this, it will not be very convenient. You will get too many duties in the end. It's the same thinking also here. So if you don't need it, you should not get access to it. Yeah, so this is mainly the idea. And if we have something like a multifunctional device, it will inherit from all interfaces. So we'll have to obey to all the contracts clauses, because it's an interface. It's a contract in the end. So if you look closer and try to understand, it's not necessarily that you have too many things in an interface. You have actually to implement them. So if you have just a simple print or printer, this printer should somehow implement scan, even though it's not something that the printer has. So maybe it's just a simple printer and doesn't have scan, but with just a single interface that has all, you have to implement scan. And maybe instead of having here something like this, you have to put an error message that scanning is not supported, and that's not okay. So this interface that contains too many things, it's in the end causing a lot of code that it's not necessarily to be implemented. So have to add different functions and or methods, and yeah, put just some weird messages there. Yeah, so this is the idea with this interface segregation, because it's not necessarily a problem to add here a lot of things. The problem is that someone has to implement these things, and if it's not necessarily to have them implemented, it's, yeah, makes no sense in the end. And of course, it's related to consumption also. It's like an API that it's offering tons of functionalities, but in the end, you don't actually need all the stuff. So maybe it's good to have some organization, and maybe different parts of the API to offer very specific functionalities. And the last one, dependency inversion. So here it's a bit more complex. Again, the main or sorry, the program contains nothing. It's yeah, just the default stuff. We will start with employee at getting some properties. Here, for the ones that are not familiar with C# 10, getter, it's just a regular get method for an ID, and this init refers to initialization on construction of the object. So it's a specific keyword introduced in newer versions of C#, but think just like an initialization on construction, nothing else. And these properties will be just read-only, will just, or let's say will be possible just to retrieve the values, not to change them via the properties. And we have business logic. This business logic, and here we can see it's hard dependency. We'll have a look immediately on the data access factory. Doesn't matter that much. The idea is that here we have an employee data access created via this factory, that it's creating actually an instance of something. And from this instance, employee data access, this method will try to call this data access method that probably will reach the database and will extract some data related to employee, and will fill in an employee object with the data from the database. Here the employee, it's an example of that anemic object. So it has only properties, no methods, no logic, nothing. It's kind of DTO, it's just a data transfer object. Makes little to no sense to have these kind of things. I know that it's a good, it's a useful approach in double quotes, useful. It's quite popular, and in a lot of projects we find something like this, but it's not how it should be. And data access, it's now just for testing purposes, just return a new employee, supposing that we are going to the database and create an instance of this employee. And the factory, it's just creating an instance of employee data access. So again, on the business logic, we have this hard dependency, right? We're getting an instance of it. How we can test this class? That's the question. Because it's a hard dependency, we cannot replace it. So it's almost impossible. We have to, yeah, fake some functionality, try to create some objects that are simulating this one, and in the end will not test the production code, but a bunch of classes created for let's say faking purposes, stubs or other kind of mechanisms for wrapping existing functionality in something that can be used for testing, and maybe add some flags. So yeah, so it's very ugly in the end. So it's not really testable, something like that with strong dependencies. Reflection maybe, but again, that's not how it should be. Okay, I will answer to some comments afterwards. So how it should look like? The employee, still it's the same for this sample. On the business logic, here I think I forgot to change something. Yeah. Yeah, I think I forgot to change this. I'll correct it afterwards. So normally here we should get no. It's okay. We have this interface here, and via the interface we can have this injection. We can create an instance because we are not depending on some instance, so we will depend on some abstraction. So this is a different way of injecting dependencies. So here is the key. Here is the difference between the two. Let's say before and after. Now, if we are going to look on data access, it's more or less the same. But instead of getting a specific instance, here we will get an abstraction in the end. Yeah, so this is the idea of dependency inversion principle. To let's say don't depend, or let's say to have loose coupling. That it's the right term to express this kind of things. Loose coupling. We have abstractions. We can replace this interface instead of reaching the database here in or we can have, for example, a fake employee data access, and this get method details to have something like this. So hard-coded in double quotes with some values that can be tested or used for testing in the end. So instead of touching the database, we can just get a new employee with some data and check if that method actually works correctly. And the last thing, we are already with time over. So before, here again, it's empty, the program, doesn't matter. We have a customer, a paper boy, so it's a newspaper seller and the wallet. So now the customer will have an initialization of the wallet with 0. So this customer will have a wallet and will get some amount on it. The paper boy, we have the selling price of one whatever for a newspaper. It's the total amount of money that he collected for selling papers, and it's a list of customers. And for each customer. So we'll iterate through the list of the customers, and if the customer is not able to pay, then yeah, we're just not selling anything. Otherwise, the money from the customer will be took out from the wallet, and will increase the amount on the funds collected. And here we have the violation of law of Demeter. So this customer is exposing too many things. So it's that chain of properties or methods that I mentioned about. It's exposing internal details that in this case create dependency, and it's also a very bad practice, because here nothing it's preventing us from changing the money that it's exposed here. If we are not careful enough to have just let's say getters or read-only properties, then here I can set money to whatever I want without any. And here it's actually just happening this by purpose. So the amount of money from the wallet it's reduced with a certain amount. So it's exposing these details without any control over it, sorry. And that's really bad. No one prevents that by mistake to have this changed. And here the wallet is just a simple, yeah, take some money and we'll keep the money amount well. So this is before, and we have seen what are the what is the bad code in the end. And now let's look on the customer. So the customer still it's getting the wallet as it was. Now the wallet it's just read-only. And we have a new method that it's make payments, that it's getting a decimal value. And as I have mentioned previously, here it's followed the command query separation pattern. So methods that are changing the state will not return values. If we want to notify some observers or so, we can use events, or as it's here, if something is not okay, we can just throw exceptions like insufficient funds. And the wallet will be, of course, the amount will be reduced here. Again, it's not 100% because we have the wallet and we have the money, and the wallet it's not necessarily okay that it's exposing this money property. But it's a step in the right direction in the end, because normally the wallet should handle these kind of things. And here on the Paperboy, it collects payments, and yeah, now we'll just call this make payment on the customer level with the price that the customer has to pay. So this is how it's looking now. Yeah, and that's it more or less. So again, you can get access here or check the code, and of course I will put also the slides here. So you can have a look afterwards. And now some questions. I know it's a bit late. Try to answer fast. Here we have just the summary. So it's critical to follow good principles consistently. And that means, and I'm emphasizing this, whether or not the project is nearing a critical deadline. So don't make, let's say, wrong, or don't take wrong decisions under the pressure. To don't follow what you know that it should be a good practice. And the key to writing high quality code is to avoid tight coupling. And of course, the rest will follow if you will apply these good principles and practices. And now some questions. Okay, about LSP. In all the situations where the override methods are not coming from the inheritance of an abstract class, like in the case of your example, means LSP is violated. It's like we can't override the method in a class that derive another one, which is not abstract class. Not really sure that I understood. So probably you refer to the fact that if there are other methods that are added into the new or derived class, it cannot replace the original one. In general, it can be if we're not somehow hiding the existing functionality or the existing state, especially in base class, by creating, I don't know, other properties, hiding the existing ones. So here it's a bit a longer discussion. Okay, other questions, if there are any. Thank you, and see you next time then. Bye-bye.